वेलकम। आप सभी लोगों का स्वागत है। आज का सब्जेक्ट जो इस कोर्स का आज का सब टॉपिक है ओवरव्यू ऑफ कॉन्सेप्ट्स DBMS RDBMS SDBMS फॉर जियो डाटा हैंडलिंग। तो शुरू करते हैं इसको। हमने 3 पार्ट्स में बांटा हुआ है। देयर आर 3 पार्ट्स इन दिस कोर्स। फर्स्ट वन इज़ द data about database and DBMS structure. Then second part will be covering the relational DBMS, and third part we will discuss about the spatial database management systems and its application in geodatabase as a geodatabase for geo web applications. So let's start with the first topic. We will discuss about the data, then database management system, types of databases, their characteristics, advantage and disadvantages. What is data? Data is a collection of distinct small unit for information. It can be used for a variety of forms like text, number, media, bytes. So everything in real life, whatever we see, observe, or which can be noted down in some form, can become part of the database. So in other words, data is originated from the word datum. That means single piece of information which is unique, and it could be identified, recorded and maintained. It's a plural, so it's combination. It's not a singular word. It can have multiple information, and interpretation also may vary. The computing data is information that can be translated into form of efficient movements in processing data. Database and its management system. There are two separate words. One is database, one is database management system, shortly called DBMS. But both words are used interchangeably. Meaning always indicates about the DBMS. So the database is organized collection of data. It can be easily accessed, managed, or which can be stored in some format. Then database handlers creates a database in such a way that only one set of software program provides access to data of all other users. The main purpose of database is to operate large amount of information by storing, retrieving and managing. Dynamic websites in background uses the database systems to produce the data based on the produce dynamic web pages based on the information which user feeds in, or different websites, different formats of data is represented in data-based websites. There are many databases available like MySQL, Sybase, Oracle, MongoDB, Informatics and many others. Microsoft SQL Server is also very famously used. Open source database system is MySQL. There are others like Postgres. SQL is structured query language. It's generally named as SQL database, but SQL is a query language which is a standard query language which can be used in multiple databases. So when we talk about the SQL, it is about the language. Types of databases, as we can understand, centralized databases where the database is stored at a central location and different locations through several applications is accessed. So there is a single server or multiple servers stored in one location, and every user has to access this database via various methods. And the security aspects or any other part of the authentication server or anything related to this database will be handled as a single port, a single interface. So there are advantages of having it as a single interface, and same time there are some disadvantages. As we talk about advantages of centralized database, it decreases the risk of data management, as manipulation of data will not affect the core data. So Additionally, there are like data consistency is maintained because there is single database. Any modification happen in the database will be stored at central location, so there is no consistency issue. It provides better data quality, which enables organization of established data standards, because we have to enforce the standards at one location, one server. The less costly because fewer vendors are required to handle the dataset. There are advantages, disadvantages of centralized database, like size of centralized database is large and it will increase with the time. So at the initial stage there will be frequency or the speed will be high, but as the time grows, database grows, this response time will be increasing very high. So we have to consider the centralized database system should have all these advantages, but disadvantage also has to be overcome in some way. It is easy to update an extensive database system. When it comes to update the database, there is no redundant system available or there is no backup system available, then it becomes near to impossible to update the database, and we have to make the total site down to update it. Same thing happens when database crashes, so backup restore procedure also takes a lot of time. And server failure due to hardware or something, that will also have huge loss. Then we comes to the distributed database system. Unlike centralized, the distributed system of data, it is distributed among the database systems in an organization, which can be physically located at one location or multiple locations. So example of distributed database is Apache, Cassandra, HBase, Ignite. There are futuristic views of distributed database, as it has homogeneous DDBs and heterogeneous DDBs based on the requirement. Advantages are like modular development is possible in a distributed database. The system can be expanded by including new computers and connecting them to the distributed system. So expansion or dynamic expansion is a clear possibility here. And one server failure will not affect the entire dataset. And if there are management of disk storage units in proper way, then even the hardware failure will not have any effect. So these are the major advantages, and this is like two types. So homogeneous means the data which is executed system, same application process and carry out the same hardware. And in the heterogeneous, there is variations in the DB system, which are incorporated and accessed in multiple ways based on the application. Then it is third one is the relational. This database system we will explain in the second category, second group of our topic in detail. Here is basics about the relational database. Basically, the relational database system is based on the theory of EF code, which the theory was given in 1970. There is a concept of tables, and database carries the key that makes the data unique from other. Examples are MySQL, MS SQL, Server, Oracle. So the concept of columns, rows, tuples, and these relations, which is called tables, is the part of relational database. Majority of databases available nowadays are relational. These basic features of relational database, which differentiate from other type of databases, ACID properties that indicates atomicity, consistency, isolation, and durability. Atomicity indicates that every access or every operation in the database is unique. Either it is completely done or it is not done at all. So partial transactions are not allowed, and this has to be taken care by the structure of data, database which is maintaining this. So it has to be ensured that the atomicity of every operation is maintained. Consistency means the data updates or transactions should have same state. State preservation is the part of consistency. For example, account balance before and after the transaction should be correct. That means if from A account to B account some money is transferred, then the total sum of A plus B should remain same before transaction, even after the transaction. So this is called consistency of database is maintained. Isolation indicates when multiple users are accessing the database at same time, then every transaction or every operation of every user should should be like it is independent or isolated from each other. That means the one operation on one database or one data set or table should not have any interference, any delay, or any misoperation should not be created due to this to the other user who is using the same database or same table. That means if you are operating on some user account, same user account, if some other user is also operating, then both transactions should have no impact on each other. They should be executed in isolation to each other. The fourth thing is durability, that ensures once it completes the operation and commit the data, then the changes should remain permanent. That means whatever changes or operations are done on the database, they should not be reverted back. Once it is committed, the database status is final. So these four properties ensure that the database is a relational database. Types of database, one part is also NoSQL. There we don't consider the sequential query language as part of this database. So there are various ways to store the data in apart from using the standard SQL type of databases. So till now, whatever databases I have explained, those have the common standards of SQL which they are following. Like you can have a select query or some queries on these databases which will be executed. But in case of NoSQL database, the structure query can be executed, but the storage units will not be in the form of tables or some other standard way. Like if you have a database of documents, you have MS Word file, one text file, one Excel file, all these things as it is will be stored as a file itself, and they will be accessed or data can be manipulated using this NoSQL database. Same time you have images, videos, audios as part of this database. So these category of databases are used for the terabytes of data where there is continuous upgradation or changes happening in the database. So this type of database is completely separate from the other standard databases. That's why it is called NoSQL. There are key values storage fundamentals here. There is simply a type of database storage where it stores every single item as a key, and corresponding value is held by that. So it's something like the pointer where there is table of keys, and that maintains this link to individual data. Like there is image, then there is a key for that image, and that is linked to this image. So this way it is maintained. There are further many operations to maintain this sequential and value holding statements. Then there are categories. They are again subdivided like document oriented database, graph based database, wide column storage. Advantages are like good productivity in application development, as it is not required to store data in a structural format. Whatever data we receive from the raw as it is saved. So there is no requirement of structuring or restructuring of the data. The raw data will remain as it is. The better option for managing and handling large data sets. It provides high scalability. As data comes, we can dump it to the storage unit and it will be linked, relinked accordingly. Indexing will be happening. Users can quickly access data from database through key values, because there is a fundamental of key is involved here. These are the four types. Then there are few databases which are part of like cloud and hierarchical. Cloud is where data is stored in a virtual environment and executed over a cloud computing platform. Uh, it provides users various cloud computing services also. For accessing a database, there are numerous cloud platforms like Amazon, Microsoft, and cloud-based Google. Hierarchical database, there is this type of databases are stored in form of parent-child relationship. So there is concept of level. At the top level, the node is called parent, and below that it is called child. This organization is like a tree structure, and it is multi-branched tree. To get the data stored in the form of records, they are connected like a link. Child records in the tree will contain only one parent, but one parent may have multiple childs. So the concept of levels and root and tree structure. There are few other types of databases like object-oriented databases and network databases. Object-oriented is type of database that use the object-based data models approach for storing data in database system. The data is presented and stored as objects, which are similar to the objects used in object-oriented programming languages. Network-based database is database that typically follow the network data model. The representation of data in the form of nodes connected via a link between them. So unlike hierarchical database, it allows each record to have multiple children and multiple parents. So by understanding the various type of databases, what we have seen, these are some few common characteristics of databases. It uses digital repository established on a server to store and manage the information. It can provide a clear and logical view of the process that manipulates data. DBMS contains automatic backup and recovery procedures. It contains ACID properties which maintain data in healthy state, and in case of failure it can be recovered. It can reduce the complex relationship between data. It is used to support manipulation and processing of data. It is used to provide security of data. It can view the data from different view angles. Advantages, as we continue from the last slide, controls database redundancy. There could be a requirement of high availability database. In such case, there are multiple database servers and services maintaining to avoid any failure. Data sharing. In database management system, the authorized users of an organization can share the data among multiple users. Easily maintained, so maintenance is easy due to natural failure or any other issue. The maintenance is taken care. Reduce time to reduce development time and maintain needs. Backup and restore, and multiple user interfaces are available. If you try to understand these advantages of DBMS, if you correlate them with a database which is not having a set of data which is not having database management system, then you can correlate very easily. If you take example of multiple files contained in your system, which is also a part of data, but it is not stored in any structured format, which is used in case of DBMS, database management system. So if you are not using database management system, your data is stored as a flat files or single files in your computer PC, then you will not have these advantages. If I compare them, like controlling database redundancy. So if we talk about redundancy, there are multiple files stored in your system. Assume that last 10 years data you have stored, or you have a school of some 50 children, and that data your file is containing, assume that Excel sheet is containing the name, their roll number, their marks obtained, their fee submitted status. Then every year you have to maintain a separate file, and if you want to compare between the last year and this year, how many changes are there, you have to open both the file panel and see it. So this type of thing is one part. Then redundancy in the case is, if there are two users using the same file, he will have one more copy. You have two attendants to maintain your records, they will have multiple copies. So there's no control about the redundancy. So that means further confusion. Second thing is data sharing. So there is no single file shared among all people. If one person modify that, then other person cannot change it. So because there is, if you shared via Google or you shared via the email, your counterpart may have updated the file, again he has to send back the updated file. So this sharing of data is not coherent. The consistency of data will not be maintained. Third thing is easy maintenance. If there is requirement to change the name of a child in your school, example, there may be modification you have done for one child, but there may that same file is not replicated everywhere, then other user may have the old file. So the maintenance is not easy. Fourth thing is reduced time. The development time and maintenance time is, obviously you have to mail to your counterpart or ask him to modify that file every time you update your file. Then synchronization of the file is also has to be maintained. So such issues are there. And backup also, like there is failure, you have multiple backups, but which backup is final is again issue. Multiple user interfaces, like you want to show somebody the final list of your students, you cannot show them because every user is not having access to that. There is no way to show your Excel sheet to everyone. So either you have to call a video conference or something. These features are available nowadays, but still the person who want to change that, he has to ask you to edit the data. He cannot do it himself or herself. So this multiple users access is not possible. So these are the advantages, but still there are some disadvantages of using database system also. The cost of hardware and software. As the speed and memory size grows, we have to maintain the hardware and software accordingly. Size also is more. You may surprise that many times the database system which we have used, like Microsoft SQL or whether it is MySQL also, there is overhead in the data. You have stored a 10 GB of data, but there will be 12 GB or almost 6 GB extra data available because of maintaining that. That data comes because of there is indexing involved in this. Whenever you update the data, every time it has to make the transactions. So the transaction log, indexing, metadata, all these informations has to be stored. So because of that, the size of database grows. It is higher than what actual data is stored in that. So this is second disadvantage. Third is complexity. As we grow, the database grows, complexity also grows. As multiple user interfaces updates the database, that maintenance also has to be taken care. Fourth is the higher impact on failure, because we have a singularity model. So if there is change in the organizational structure or due to some failure, if the hardware fails or the database is lost, we don't have any other system of backup. So to overcome these complexities, size, hardware, software issues and failure issues, we have revised the structure and following some standards to overcome these failures or disadvantages. The second part is the relational data model. We will cover here like brief history of relational database model. What is relational? As little part I have explained already. Then model concepts, integrity constraints, relational model operations, best practices, advantage and disadvantages. Then we will come to the sample queries, how the queries are executed and in real time how it works. As I explained, Dr. E.F. Coate has given a seminal paper on 70s, which was the base or fundamental of creating a relational data model. Dr. Coate gives set of rules which were followed by the database model, then it is called relational database model. So there are few things, like there are a collection of tables, there are few rules, and there are a set of operators to act on tables. Data types, relation between tables, SQL queries. SQL queries are again subdivided into data definition language, data manipulation, manipulation language, and data control language. Indexing basics, these things we'll cover here. What is relational model? It is database as collection of relations. Relation is just a table in simple format, simple language. Any relation is a table. So every row in the table presents a collection of related records. These rows in the table denote a real world entity or relationship. The table name or column names are helpful in interpreting the meaning and value of each row. In the relational model, data are stored as tables. However, the physical storage of data is independent of the way data is logically organized. Here the concept of abstraction also comes in picture. Physically on the hard disk there may be storage methods to store the data on hard disk, but representation of there is some columns and rows which contain some data. They have some rules. So let's understand what they means. The attribute, each column in a table, attributes are properties with which define a relation, as student roll number, student name, student date of birth. So these are the attributes, like the column names in a table, which are representative of the values stored in that column. Table, the complete table is a relational model, so it's like a relation. So that may contain like student roll number, student name. So what is the relation between student roll number and student name is represented by the table. So there may be first student who have some name, and that name contains some roll number. So the roll number and the name are correlated. So that relation is represented in the form of table, and it is called the relational data. Tuple is a single row. So for example, roll number 1 contains name, some XYZ. So that name has the roll number 1, and that information alone is tuple. There may be one more tuple containing roll number 2 having some name. So every row is a tuple. Relation schema. The relation schema represents the name of the relation with its attributes. So this let's differ a little bit. I will explain this in the next slides. Then degree. Degree is total number of attributes which are a relation, which in the relation is called degree. So if the table contains 100 records, we may call that the table will have degree of 100. The total number of attributes which is available in the record. So how many attributes we have, that is called degree. Cardinality, the number of rows represented in the table. So we can say that the number of columns are degree and number of rows are cardinality. Then what is column? Column represents the set of values for a specific attribute. Relation instance. Relation instance is a finite set of tuples in RDBMS system. We can understand as a table for assume that the fee structure of students are given in that table. Then for this month, assume month of November 2021, how many students have given fees, submitted fees, that information is stored in a table, and next month it has to be updated. In such cases, every month whatever information available in that table is the instance of that relation table at this month. So this way we can understand what is the instance. That instance for my example here is monthly updated, but there may be issues, there may be examples where every second the instance is updated. Then it comes the relation key. Every row has one, two or multiple attributes, which is called relation key. Attribute domains. Every attribute has some predefined values, like student name may not contain numbers. So this is the domain. Domain is only alphabets, in the name column. So this way we define every database in these concepts. Let's understand further. For this example, customer name, status. The first customer ID is the primary key here. This table is called relation. Columns or attributes are indicated here. So total number of columns is the degree, and the number of rows, which is tuples. So here are 3 tuples. So the total number of rows, as we understand as cardinality of this table, is 3, and same time the number of columns in the degree is called degree. So this is also degree 3 relation. Relational integrity constraints. As we have understood, there are some fundamental rules to be followed by the relation database. So there are called integrity rules. There are integrity constraints. So relational integrity constraints is referred as the conditions which must be present for a valid relation. These integrity constraints are derived from the rule of mini world that database represents. There are many types of integrity constraints. One may be like domain constraints, as for example I have told that student name cannot contain number. This is the constraint to be followed by the name table or name column. So the domain of the name is defined. It has the limitations. It has predefined set of values which can contain. Then second is key constraints. There are some definition of keys. There are multiple type of keys. We will explain that also. Then referential integrity constraints, where one relation has some reference to the other relation, and it has binding constraints to follow some rules from the other table or other relation and maintain the child or the referential integrity constraint in the new table. So let's deeper in domain constraints. That can be violated if an attribute value is not appearing in the corresponding domain, or it is not in the appropriate data type. So if we have some column containing money value in rupees, there is limitation of not having any alphabet or special character. It can have only the numerical values. So the domain of that column is numbers. Domain constraints specify that within each tuple and the value of each attribute must be unique. That has to be maintained some way from the keys also. So the data types, which include standard data types, integers, serial numbers, characters, boolean, and variable length strings. Example of domain constraints is like customer name. Then we will put check. So this is the constraint we are forcing on the customer name table or customer name relation, and the check value is not null. So the check value is not null. This is the example shows how creating a domain constraint. So the customer name cannot be null. Whenever we enter the data in this table or in this relation, we have to ensure that the customer name is not null. This explain about key constraints. The attributes that can uniquely identify a tuple in relation is called the key. So the value of attribute for different tuples in the relation has to be unique. For example, a given table customer ID is a key attribute of customer table. It is most likely to have single key for one customer, like customer ID 1 is only for the customer name Google. So if there is repetition, the customer ID also will be repeating. So there are complete binding or constraint about the customer ID and the customer name. Then referential integrity constraints. Referential integrity constraints is based on the concept of foreign keys. The foreign key is an important attribute of relation which should be referred to an other relationship. Referential integrity constraints states happens when the relation refer to a key attribute of the different or same relation. Here for example, we have in the last slide we have seen that the Google is given the key customer ID as 1. Now when we have to refer something like every month, or there is every transaction has to be recorded for Google, then invoice number and the customer ID and the amount, these three are stored in a billing table or billing relation. So the customer relation and billing relation has to be binded by the referential integrity constraint, which is defined as this referential integrity of customer ID has to be maintained from the customer table to the billing table. So whenever a transaction happens or invoice is to be printed for customer, the customer ID corresponding to the customer table has to be entered in billing table. If there is some billing for a customer ID which is not existing in the customer table, that is invalid. This has to be defined in proper format, and this is called the referential integrity constraint. Operations in relation model, there are multiple operations like select, project, product, unique, intersect, differential, join. So these are the relation model methods. They are somewhat common like our set operations. So we'll go further. Best practices of creating a relational model. Data need to be represented as a collection of relation. Each relation should be depicted clearly in the table. These are the basic practices which can be used for relation model design. From the real world entity, when we are going to design a database, we have to consider these things and practically understand they have some advantage at immediate or some advantage at later stage. So if we follow from the starting, from the design onwards, the database will be having all the advantages of database system. Column must contain data about attributes of entity. Cells in the table should hold a single value. Each column should be given a unique name. No two names can be identical. The value of attribute should be from the same domain. Advantages of using relational model: their simplicity, structural independence, easy to use, query capability, like the SQL statements we can execute on this database. Data independence, the structure of database can be changed without having change on any application. Then scalability, we can increase the database size, include some more nodes in the database. Disadvantage of using the relational model: few disadvantages are like fields have some limitation which we cannot exceed from that value. Relational database can sometimes become complex as the amount of data grows and relation between pieces of data becomes more complicated. Complex relations database system may lead to isolated database where the information cannot be shared from one system to other system. So these are few issues. Then there are some methods to overcome them. Now let's come to the sample, how to write the sample queries and execute them. This is some referential table. Based on this table data, we will be executing some queries and explaining them. We have 4 columns, namely complaint ID, product, company, and zip code. There is 2 additional columns, first one as a index value and the last one as a address. So for this query, we are going to select the ccd dot complaint ID, comma product, comma company, comma zip code. So the 4 columns we have selected here, and then from where to select, then we have given one more query inside the from. So this is called cascading queries or subqueries. In the subquery, again we are selecting the 4 columns, and from the table name just now shown in the last slide here, and zip code equal to 91701, and this is called CCD. So the top level, when we are selecting ccd.complaint ID, it is selecting from this CCD here. This is called giving LIs. So we are giving LIs name to the credit card complaints table. So we will get the output like this. So out of many records, only few records have come here. 7 records have come. In fact, 8 records have come. So these 8 records are only for the zip code 91701. So this is way of querying the data from the relational tables. Now we come to the third topic, which is spatial data. After learning from the data to database systems and then relational database systems, these type of systems cannot be used for the geo web services or geo applications, because there is some limitations or some requirements additional to these databases which are not fulfilled by these existing database systems. So we need a separate database system or some modification in these database systems to make it usable for our systems, our JS applications. So let's explore more. In spatial data types, we have fundamentally 3 units: point, line and polygon. So how we will represent in these real-time entities in the format of digitization. So points, it can be represented by 2 real numbers, x, y. Line is a sequence of points, so again sequence of x and y's. Region are included inside endpoints, so there are multiple points but not in the sequence. Then it is comes as a polygon. So how the spatial relationship will be maintained? Topological relationships like adjacent, inside, disjoint, and directional relationships above, below, north or south. Metric relationships like distance less than 100, and operations to express the relationships. So now we have come to a situation where the existing database till now explained are not usable because they cannot answer our queries like topological relationships or directional relationships. So we need to design something which is having the formats to query or answer our such queries. So spatial relationships, let's understand the topological relationships. Either it is containing or overlapping. Metric relationships, so A to B. So third is direction, A is above B, north of B or south of B. So these are the physical representation or real life example representation of spatial relationships. Spatial queries, find all objects inside query Q. So again, inside could be like intersecting, nearest neighborhood queries, spatial join queries, like two spatial relations S1 and S2, where S1 is one table and another S2 is another table. So to find all the pairs X in X S1, Y in X2, where X is related to Y, and the relation could be intersection or inside. So such a way we have to identify all these points and identify the image which or the section which contains this spatial join queries are used to identify such spaces. There are indexing, spatial indexing, point access methods versus spatial access methods. In points access method, index only points data. So hierarchical data structure or multidimensional hashing, space filling curves are used for this type of indexing. There is another indexing SAM, where spatial access methods are used. Index both points and regions. So transformations, overlapping and clapping methods are used. Now how to identify the real life image, real time image. So different indexing methods are used, and in case of collection of polygons, instead of indexing the object geometries themselves, whose shape might be complex, we consider them approximation. So the method of approximation is also used. Now most commonly used approximation is minimum boundary rectangle, which is called minimum bounding rectangle, MBR. So minimum bounding box also we call it. So in this example, like we are seeing here, there is one image and that image is not in proper shape to identify something in standard formats. So we cannot put them as a line or in a box. So we have tried to put it in a box so that we can identify the image by referring the four corners in our database or in our digitization format. So what we have done is we have taken approximation here with minimum bounding rectangle. Now if we identify point in the polygon xy for here for this example, the xy is also falling inside the rectangle, the MB bar which we have defined last slide. So when we have to identify the points, majority of points which are under this polygon are also part of this rectangle. So this way the approximation is done. Spatial indexing methods. There are various methods for quad tree, octree, R tree, R plus tree, R star tree, and most popular used for spatial database management system is R tree and quad tree. We'll discuss something about the R tree here. R tree is based on the MBRs, which is explained in last slide. So minimum bounding rectangles will be defined for each image. Then defining the indexing 2D objects can be extended to higher dimensions by implementing only 2D in Oracle Spatial. MBRs of geometric objects from the leaves of the index tree, and multiple MBRs are grouped into large rectangles to form intermediate nodes in the tree. So now we are trying to understand the structure, how to store the physical image or the spatial data in format of digital format and in the form of tree for various further operational purpose. Let's have the example. There are 9 shapes. This spatial data has to be grouped and a R tree has to be created. So what we will do, we will find the nearest neighborhood and apply the MBR. Then we make the tree fundamental, the basic layer of the tree. So pointers to geometries are created. So 9 pointers to the geometries are created. Now we have identified them and grouped them. So start the grouping format. 1 and 2 can be grouped because they are nearby, and we create A, second B, third C and D. Now we create one more layer. So this is the reduced format. Earlier we have 9, here we have 4. The further grouping we can create 2 more. So another level, and the top total geometry is covered as a root level. So that becomes the R tree format in our database system. Now this R tree 3-layer structures can be used for 3-layer structure. SDBMS work with the spatial application of front end and the DBMS at the back end. So they have 3 layers: interface to spatial application, core spatial functionalities, and interface to DBMS. That means the SDBMS is extension or modification or updation of the standard DBMS systems. So the database systems are used as a root or building blocks for creating the spatial database management system. In this example, this is overall structure. There is fundamentally the DBMS working at the bottom level, and on this we have interface, and with that interface we are having some core spatial functionalities implemented over this DBMS, and then we have one more interface to connect with the spatial application where the data is stored in the root DBMS only, but processed for taxonomy, data types, operations, query languages, algorithms and access methods, and represented in a spatial format for the spatial application. So SDBMS, the organizing and management of geospatial data inside DBMS or RDBMS, has emerged as an exciting and challenging area of JS professionals during last year is known as Spatial Database Management System. Geodatabase is common data storage and management framework of ArcGIS combined geo spatial data with database data repository to create a central data repository for spatial data storage and management. It can be leveraged for desktop servers, mobile environments, and allow users to work on GIS data and location based data. So one is geodatabase model. Functionalities are GIS data, multiple user database, single user database. All this structure has represented in a proper graphical format here. Based on the requirement, we can use for a mobile or servers. Spatial data entity creation, how to create that. So now we have come to the design part again. After understanding the basic structure, how this spatial data is stored in the database system. So the interfaces works fine. Then we can create like normal table in database system or RDBMS. For SDBMS also we can create table like country with the name, state, and population, then shape. Here the shape is the part which is spatial in this database system. Otherwise remaining 3 columns of this table or this relation will be equivalent to the relational database model. So let's see how we store them. Another is river, where we have a shape of line string. So here we have defined shape as polygon for the country. For the river we defined the shape as line string. And now find all countries that border of particular country. So how we put the query? The querying also will be where touch. So there are fundamentally there are some operations also defined on the database system, DBMS system, to enable the spatial queries run on these database systems. Another is intersect. So where intersect is again one operation defined in the interface model of the database system. PostGIS is one database which supports the spatial database system, which is open source also. So you can download that and try applications development in this database system. You can try to create tables and store the geospatial data in them. PostGIS is specially enabled. Actually PostGIS when you install by default will not have these features enabled. So with a single command you can enable them and start the operations, allowing it to use in backend spatial database and geographic information system. PostGIS follows the OpenGIS standards, so simple feature specification for SQL, and types and functions are being already compliant with. PostGIS development was started by Refraction Research as a project in open source spatial data technology. Then this has come in the practical purpose. It is available now and it is free. And type of queries, PostGIS we can execute as distance, equals, disjoint, intersect, touches, crosses, overlap, contains, intersect, length, area, centroid, and corresponding inputs are defined. When you come across and start using this PostGIS, it's simple. You will come across these things and you can run yourself these examples queries to find some two shapes if they are overlapping or intersecting, how much is the length of river. You can find out with the single queries in your database. Spatial database applications, GIS applications, maps, other applications for VLSI design, brain mapping, medical applications, traditional applications, multidimensional records,